Welcome to online video training for the CTI Workbench Integrated Development Environment. This is Course 1, Part 7. Using the Fieldbus Editor. Running time, 28 minutes. Let's get started. Before learning to use the Fieldbus Editor, it's important to understand some basic concepts. A configuration is the top-level Fieldbus object, which refers to a single communications channel, employing a specific protocol. A master port is a child object of the configuration. The master port is an individual connection to a target object. For example, for a CAMP client configuration, the master port is the IP address of the target CAMP server device. Multiple master port objects can be added to each configuration, except in the case of DataCache, which allows only one instance. A slave data block is a child object of the master port, and is equivalent to a read-write command for a specific register type. For example, in the CAMP client configuration, the slave data block is a command to read or write V memory. Multiple slave data blocks can be defined for each master port. A variable is a child object of the slave data block, and ties a specific read or write operation to a variable in Workbench. Multiple variables can be defined for each slave data block. A completed Fieldbus definition includes all these parts, arranged in a hierarchy. The configuration shows what protocol to use. The master port links to a specific device IP address. The slave data block describes what command to use and what register type. The variables link the commands to Workbench variables. Workbench currently supports 13 protocols. 6 of these are classified as basic and are covered in Training Course 1. The remaining 7 protocols are classified as advanced and are covered in Training Course 2. Note that not all protocols are supported on every product. The CAMP client protocol allows communication with all CTI Ethernet interfaces, which are included on these 8 CTI products. We retain compatibility all the way back to the very first SIMATIC 505 Ethernet connection, the 2572, introduced in 1995. The CAMP client protocol is restricted to reading and writing V memory only. The CAMP server protocol communicates with any CAMP client, such as 2572 modules, or SCADA systems, answering requests for data from Workbench. The CTI 2500 DataCache protocol communicates with a single 2500 series CPU, using the optimized DataCache protocol. The interface supports a large quantity of data, up to 4096 variables, and provides direct access to all PLC data element types. CTI 2500 ACP1I/O protocol communicates with a 2500 series, or SIMATIC TI 505 PLC, using the I/O backplane interface. You can transfer of up to 32 discrete inputs, 32 discrete outputs, 32 analog inputs, and 32 analog outputs between the controller and the ACP1 during the normal I/O portion of the controller scan. This guarantees that data transfer between PLC and ACP1 module is completed each PLC scan. CTI PLC, local I/O, communicates with I/O modules plugged into the local base of a 2500P, C2000 series PLC. This can include 4, 8, or 16 modules, depending on the base type. CTI PLC, remote I/O, communicates with I/O modules plugged into remote bases attached to a 2500P, C2000 series PLC. This can include up to 15 bases, with 4, 8, or 16 modules, depending on the base type. This remote I/O system is backward compatible with SIMATIC TI 505 and CTI 2500 series remote I/O bases, which use 505-6851 and 2500 series classic or compact remote base controllers. Advanced protocols supported by Workbench include Ethernet IP, Modbus, and Profibus. Ethernet IP I/O scanner provides communications with devices such as drives, motor starters, and I/O blocks that act as Ethernet IP adapter interfaces to the network. The Ethernet IP scanner initiates an I/O connection with the device, and then produces output data to the adapter, and consumes input data from the adapter. The I/O data is transmitted using UDP implicit messages. Ethernet IP tag client provides communication with Allen Bradley Logix controllers by reading and writing tags directly in the Logix controller. Ethernet IP tag server provides communication with Allen Bradley Logix controllers and popular SCADA software by allowing them to read and write tags in the Workbench program. Ethernet IP adapter communicates with Allen Bradley Logix controllers or other devices that can function as an I/O scanner or SIP generic message client. When configured as an I/O adapter, it communicates via implicit I/O messages, consumes output data produced by the scanner, and produces input data which is consumed by the scanner. This interface is used primarily when repetitive, real-time data exchange is required. When configured as an explicit message server, it provides one or more vendor-specific objects, containing data that can be read and written by the SIP client. This explicit message interface is used for general-purpose communications, such as configuration, data access, and diagnostic status monitoring. Modbus Master allows polling of Modbus slave devices over Ethernet or serial connections, depending on product. Modbus Slave allows the Workbench application to answer Modbus queries. Profibus Master communicates with I/O modules plugged into Profibus remote bases, attached to a CTI 2500 PC2000 series CPU. This can include up to 112 bases, with 4, 8, or 16 modules, depending on the base type. This remote I/O system is backward compatible with SIMATIC TI-505 and CTI 2500 series remote I/O bases, which use Profibus RBCs. Also communicates with any other Profibus slaves, meeting with DPV1 Profibus specification, like variable speed drives. Now that we've seen the capabilities of the Fieldbus Editor, let's learn how to use it. To start the Fieldbus Editor, first make sure your project is set as the startup project. Then click the Fieldbus configuration icon in the toolbar at the top. The Fieldbus editing screen comes up. This is the editing window where the communications hierarchy will be constructed. The details for the selected item will appear here. And the details for the child objects of the selected item will appear here. The icon toolbar on the left is used for building and editing the configuration. These icons allow you to add a new configuration, master port, slave data block, and variable. The move up and down icons allow you to reorder items. You can temporarily disable an entire configuration here, which removes it from the runtime, but keeps it intact for later use. Finally, you can sort items using this icon. To prepare you for the practice exercises at the end of this video, we'll go through step-by-step examples for configuring I/O, CAMP client, and DataCache. First, click the Insert Configuration icon. The protocol list comes up. Expand the All category, and select CTI PLC I/O. Click OK. Note the local base has now been added. Click the Insert Master Port icon. The Module Select dialog will come up. Here you can select which I/O module is installed in the slot. We'll use 2558 8-channel analog input module. You can enter a description, and the slot number where the module is installed. If we tick this box, Workbench will automatically create the I/O map for this module. And then if we tick this box, Workbench will automatically create new variables, based on the prefix we specify, and attach them to the I/O points. Click OK, and the module will be added. Expand the local base, and slot 1, to see the finished configuration. Note that channel AIO1 through AIO8 have been created, and each has been tagged with a Workbench variable which will receive the values of the input channel. The module error variable will be true when there is a failure on the module. All the variables have been created, and they show up in the global variables list. If your variables already exist, you can insert the module without automatic variable creation. Just make sure the box isn't ticked. Then, after the module is inserted, drag the variable to the desired point in the module. You can also use a completely manual process. Just make sure all the automatic operations are off. After the module is inserted, drag the variables over to the module. Then select the correct operation and offset for each variable. Working with remote I/O is almost the same as local I/O. We'll collapse our local I/O configuration to save space. Add a new configuration and select CTI PLC Remote I/O. The remote I/O is added. To add a remote base, highlight the remote I/O and click Insert Master Port. A new remote base 1 gets added. Select it, and in the Details pane at the right, we can set the parameters of this base. Select the remote base address, 1 through 15, from the drop-down list. Check the boxes if this base is on coaxial cable, uses dual RBCs, and uses dual power supplies. Adding I/O modules works the same as for local I/O. Click Insert Slave Data Block. Select the desired module, and enter the parameters. We'll automatically create variables, and call this one Incinerator 2. Click OK, and the module is added to the base configuration. To add another remote base, click Insert Master Port. And a new base is created. We'll make this remote base 2. As before, you can set parameters here for the second remote base. In the next free exercise, we'll configure a CAMP client connection to read and write 5 words of V memory to a remote 2572B module. We'll start by creating all the variables we'll need. To save time, use the multivariable creation tool. This tool creates a group of numbered variables, according to the parameters we specify. This field is the pattern for the name. The %wildcard is where Workbench fills in the number, as the variables are created. Since we'll only do 5 variables, we need only a single digit, so only 1% sign. Then specify the variable type and the beginning and ending numerical values. We'll go from 0 to 4. In the Overview section, you can see a preview of the result. Click Create All to continue. And the variables are created. Then we'll repeat this process for the vout variables. After the variables are created, we can make the CAMP client connection. Add a configuration. And select CAMP client. Add a master port, and give it our IP address, 172.18.9.155. Add a slave data block. We'll do the read first. The starting address for the read is V1000, and a length of 5 words. For activation method, you have 3 choices. Periodic activation makes this a polled operation, with a repeating period you can specify. Triggered operation allows you to trigger this read, based on the value of a Boolean variable in Workbench. On-change activation is applicable only to write operations, and causes the variable to be written to the remote device whenever it changes in Workbench. We'll set the polling period for this read to 500 milliseconds. Now that the read command is created, we can simply highlight it and drag our desired variables into the child details pane. You'll note that the offsets are all set to 0 initially. To automatically renumber them, select the command, right-click, and select Renumber Offsets. Now they're renumbered in order. You can also edit these individually, if desired. If we wanted to make our read command triggered instead, we can change it here. And then use a Boolean variable as a trigger. Let's use the motorrun variable from an earlier exercise. Just drag it down here, and then edit the operation parameter. For a trigger, we can select either a one-shot or an enable. For one-shot, the read executes once, when the trigger goes from false to true. For enable, It executes continuously, for as long as the trigger is true. We can also add error variables to inform our Workbench programs about the status of this camp read operation. Just highlight the read command and add a variable. We'll call this one error 2572. Then edit the operation. Error status is the real-time status of this read command, updated each time it is executed. Click OK, and then Workbench prompts us to create the variable. It needs to be an integer, since it must contain an error code. Repeat this process to add the last error variable. Last error contains the error code from the last failure, if any, of the read command. Our completed command will execute once, when motor run goes from false to true. It will read from the remote 2572B, 5 words of V memory, starting at V1000. The data read will be stored in the variables V1000 in through V1004 in. And error status will be maintained in the two error variables. We can use the same process to create the write command. Add the slave data block. Make it a write. Starting at V2000, for 5 words. We'll take the default of periodic, and 1000 milliseconds. Drag the variables over, containing the values to be written. And then renumber them. If we skip the error status configuration, then this one is completed. Let's test this camp client connection in a remote target. We'll need to disable the local I/O configuration, since our target is an ACP1 module and doesn't support local I/O. We'll compile and download. Then run it. In this split screen with 505 Workshop, we can see the 2 blocks of V memory in the remote PLC. If we set these 2 locations to the values 1 and 2, you'll notice that they're not being read by Workbench, since the values are still 0 here. But if we activate the trigger, then they're updated. Then if we set the values of the output variables, they're updated over in the PLC, since the write command is executing every second. In the last free exercise, we'll make a DataCache configuration to exchange some information with a workshop-based PLC. Recall that DataCache is a special high-speed connection, which gives you access to all memory types in the PLC, and you're allowed one DataCache connection in the Workbench project. We'll use DataCache to connect to our host PLC at address 172.18.9.141. We'll read control relay 460 into the Workbench variable interlock, and write the variable set.6 to loop set.1. Let's collapse our other configurations to make space. Create the 2 Workbench variables. Interlock, which is a Boolean, and set.6, which is a real. Add a configuration, and select DataCache. Click OK, and the configuration is created. Insert master port. Address 172.18.9.141. PLC time slice is the maximum time allocated in the scan of the workshop PLC for communications with this connection. We'll keep the default. Interface type is LAN. We'll set the host controller connection status bit to 1. That will cause the workshop PLC to maintain the status of this connection in bit 1 of STW267. Click OK. Next, insert slave data block. Select Control Relay from the drop-down list. Enter starting address 460. And the cache direction is read from PLC. We don't need to declare a variable, since we already created it. OK to continue. The read command is added. Drag the interlock variable we created into the details pane. Expand the command so we can see it. Good. Insert slave data block to add the other command. Select the loop button and the loop setpoint memory type. Starting address is 1. And this will be a write to the PLC. No variables to declare. OK to continue. Now attach the set.6 variable we created earlier. Expand the new block. Everything looks good. Our completed configuration will read the value of C460 into the variable interlock and write the variable set.6 into LSP1. Now that we've learned how to set up the basic Fieldbus configurations, let's do some exercises. In exercise 3A, we'll create a local I/O Fieldbus configuration. Configure an 8-slot base according to the chart below, using 2589B, 2597, 2558, 2562, and 2501. Add a configuration, and select CTI PLC Local I/O. Insert master port to create the base, and select 2589AB, 32-point module. This will be slot 1, and we'll automatically create all the variables. Insert slave data block, and this will be a blank slot. Slot 3 has a 2597, with automatic variable creation. This is warning us that since we haven't entered a unique prefix for this module, the automatic variable creation will generate variable names which already exist from slot 1. We'll say no, and then enter a prefix, slot 3. Add another blank slot. Then slot 5 gets a 2558. Slot 6 also gets a 2558. (2562) in slot 7. And a 2501 in slot 8. That completes our configuration. We can inspect the I/O configuration to confirm all the variables are there. In exercise 3B, we'll create a remote I/O configuration with 2 remote bases. In each base, install a 2589B in slot 1 and a 2558 in slot 2. Use automatic I/O mapping, but do not use automatic variable creation. Collapse the local I/O configuration to make space. Insert configuration, and select CTI PLC Remote I/O. Insert master port to add remote base 1. And again, to add the second remote base. Set the base number to 2. Highlight base 1, and insert slave data block to add the first module. Select 2589AB, 32 point. Enable automatic I/O mapping. Then repeat for slot 2, selecting 2558. Go to remote base 2. Add the 2589. And then add the 2558. Inspect the configurations to be sure the I/O addressing was done. In exercise 3C, we'll make a camp client configuration to read V327 from a 2572B at address 172.18.9.155 and store into the variable set.1. First, create the variable set.1, which is an integer. Collapse our remote I/O configuration to make space. Add a new configuration, and select Camp Client. Add a master port, and enter the IP address of the 2572B. Add a slave data block, and this will be a read command. Starting address 327. Now attach the variable. Too many variables to search through, so we'll do it manually. Type in the first few characters, and there it is. Click OK. And OK again to exit. Read V327 into set.1. Looks good. For exercise 3D, We'll make a DataCache configuration. Connect to a host PLC at 172.18.9.141. Read WX1 through WX8 into the variables analog1 through analog8. Write the variable loop1 setPoint into LSP1. Create the variables we need. Loop1 setPoint, which is real. Then use the multivariable creation tool. Use the prefix analog. Make integers running from 1 through 8. Collapse our camp configuration for space. Insert a new configuration. Select CTI 2500 DataCache. Insert master port. IP address 172.18.9.141. Now insert slave data block. Select analog IOWXY. Starting at 1, and read from the PLC. Find the 8 variables we created earlier and drag them into the details pane. Renumber the offsets. Insert another slave data block. Select loop and loop setPoint. Select write to the PLC. Drag the variable we created into the details pane. Expand our commands to check everything looks good. That completes Course 1, Part 7. Here's a summary of what we've covered so far. Introduction to Workbench in IEC 61131. Basic concepts of Workbench. Getting started programming in Workbench. Programming in ladder diagram. Programming in function block diagram. Running on a remote target. And using the Fieldbus Editor.